Welcome back. We already have a sample that we're sort of interested in, but as this is an exercise exploring antimicrobial resistance, we want to see if the reads have any hit to any genes that are important in antimicrobial resistance. So I want to introduce you to BV-BRC's Metagenomic Read Mapping service. And this is a service that can be used to detect antimicrobial resistant genes and also virulence factor genes. Once again, we're looking at a sample from this collection that was collected from people who had had orthotic devices and then had a septic infection and they had to have the device removed, and they were testing them to see what bacteria were causing this. So let's talk a little bit about the pipeline that we have at the BV-BRC. And remember, at BV-BRC, generally we bring in pipelines that are well established in the community, and we just wrap them to make them easy for you to use. We also have those pipelines on GitHub if you would like to just take what we have wrapped and use it yourself. So this pipeline in the Metagenomic Read Mapping service depends on KMA. It's based on that. And this was a pipeline developed by Clausen et al. In the Arestrup and Lund laboratories at Denmark Technical University. That's a powerful bioinformatic group there. And actually, I like a lot of things that Philip Clausen has done. He's a really great bioinformatician. So it's using KMA, which is a K-mer alignment. So it's not doing BLAST, which would be looking at whole genes. It's looking at a section of K-mers, a smaller section of those genes, and it's taking the reads from this. Remember, it only uses reads, and looking to see how many of those reads map to specific K-mers. So when the job results come, it's going to show the strength of the hits, or the number of reads, sort of. That's really strength to the hits that are in the reference database. The databases, let's talk about that. There are two featured databases that you can blast your reads against. One is the virulence factor database, and that is from a group out of Beijing. It's considered a gold or even platinum standard of databases for virulence factors. The second one that we use for antimicrobial resistant genes at this time is CARD, the Comprehensive Antibiotic Resistance Database that comes out of MacArthur's lab. That's a long-standing database that a lot of people are using. Now, I recognize that there are other databases out there, but this is the one we're currently looking at. Another thing that you can do now that was recently brought into the Metagenomic Read Mapping service is you could have a feature group of things that you're interested in yourself, or perhaps FASTA files that you have. So you could even take this out of antimicrobial resistance or virulence factors if you had something that you were really interested in and you have the FASTA files or the feature groups, and you could just use this to look for hits in those reference databases. So we'll show you all of those three options, using the reference database, using the feature groups, and using the FASTA files. So one of the things we're going to be exploring when we're using the feature groups and FASTA files is the genes mentioned in this particular paper by Tristram et al. And they looked at the antimicrobial resistance genes in Haemophilus influenzae. If you recall, we identified Haemophilus influenzae in that taxonomic classification job that we did just before this. So we're going to look for these things. Now, some of them are beta-lactamase genes. If you remember, those are important in antibiotic resistance. We also have the penicillin binding proteins. They generally go by PBP, but that's an older notation for them. Now they have new names like FTSI, and we'll go over those too. So this is the landing page for the Metagenomic Read Mapping service. And in the next video, we're going to start submitting jobs. So I'm looking forward to seeing you there. Bye.